So we're up to new texture streaming. Sometimes we want to render pixel data from a source other than a bitmap like a webcam. Using texture streaming, we can render pixels from any source. So texture app class, we are going to add some function, let's say create blank and these three new functions. Texture streaming. Alright. So we move on to this. Let me just generate CDAX. Texture. So in texture, I want to create a texture, returning a texture to this create blank. Create blank. I can take the width and height. So width, height. Creates a blank texture of desired dimension. Okay. And then I have these functions. Copy raw pixels, white pixels. The copy raw pixels, lock texture and unlock texture. Okay. Fine. Copy is setting. Right. Copy raw pixels. Texture. Raw pixels. 32-bit pixels. Taken the texture. Void pixels. Copy the raw pixels. We have lock and unlock texture. Alright, so then we have raw pixels and raw pitch. So we define it, raw pixels pixels and raw pitch. Here we're adding more functionality to our texture class. The create blank function allocates a blank texture that we can copy data to when streaming. Okay, so it's a blank texture so that we can stream data to it. The copy raw pixels function copies in raw pixel data we want to stream. Okay. Copies raw pixels data that we want to stream. What's also important is the lock texture, which gets a pointer send pixels to, and unlock texture which uploads pixel data to the pixels. Okay. Okay, we also have mraw pixels and mraw pitch to store the data until we send the data to the GPU. Okay, so lock, it's important is lock texture which gets pointer to send pixels to. Okay, so we gets the pointer to which we wish to send pixels. Wish to send pixels to. And lock texture basically what it does is lock texture which uploads pixel data to the pixels. Okay. Uploads pixel data to the pixels. We have mraw pixels in mraw pitch to store the data until we send the data to the GPU. Used to store the data we used to store the data until we don't send it to the GPU. Then we have a test animation screen. So I would have to create two new files. This is data stream. Right, so we have this data stream, load media, and then thing the data current image delivery. Load media free and gets current frame data. Get buffer. Here's a let me write it up. Okay, so stretch data stream. Right, data stream. Within the data stream, I have a still surface, so I should think load media. Create blank. Do we define load media for that? Copy raw pixels, media. Yeah, okay. Get buffer, streaming texture, render, get buffered, data streams. Okay, fine. The main loop rendering without screen. Okay, I just want to take a look at what the output is here. I think I would have to change something around here. Oh, sure. Okay, I want to see data stream. I think I can jump to its definition. F12. No? Okay. There we go. Data stream loading. So it is basically we are loading textures, right? Basically the format screen. Right. Copy of pixels, of texture. Okay. So just want to go here. Include some files. Page. Then image. Then I have to use image of, okay, we have array of pointers, still surface pointers. Okay. So surface images, and we have four images. Then we have current image, and then we have delay frame. So alright, so then we define some functions, data stream create, then I have load initial data, initializers, internals, load media, data stream, load media, we have a deallocator, void, data stream, destroy, stream here gets the current frame data. It's the initial data. It's the initial data. Gets buffer. Gets the current frame data. Frame data. Deallocates the include sugar h. Here is a data stream class. We won't go deep into how it works because we don't really care. When dealing with webcam, video recording, etc., APIs they typically don't go deep into how they work because all we care about is getting the video and audio data from them. All we really care about is that get buffer function which gets the current pixels from the data buffer. Okay, pixels from the data buffer, so just save it. 8. Then I have boom, data stream, load media. Sure. I don't think, yeah, I would have to include a pretty boot. Okay, so let me copy these. Okay, so yeah, so all we care about is that get buffer function which gets the current pixel from data buffer. So we can create data stream that equals Alex size data stream that so should include debugger h. Check then should fail create the data stream. Let me define error Then we set temp of images 0 to 3 should be null. Equals null. 3, 2. Then what else? Okay, this is the grade plan. Is there lock texture, copy pixels? Okay, so current image, okay, current image is 0 and delay. The frames, I think they should be fixed. Check it. So, delay frames is 4. So, then current image is 0. Then delay, delay frames equals 4. Then we return. Okay. Alright. So we can go media. Walk. Okay, so it is just we check loaded. Okay. It's concatenating the string path. Right? Path is a plus a plus dot png. Okay. Then we load the path here and then we check loaded surface with ing load, which is STL convert surface format, loaded surface, and we see the loaded surface. STL surface convert thing. And I can create texture on surface. We don't need the texture. We are just loading. So STL convert surface format. Need the format and pass in the 0. So that is all we have to do here. Here. I need to find another input media. Surface, right? STL surface. Okay, that is actually a very good thing. I think I should include STL dot fetch. So to define yeah, fetch. key string. Let's see, key string path, right? Key string, right? I key string D from CSTR. Right, okay. So key from CSTR. Key string path equals key from CSTR, and I have to get the path which is assets, then it's called foo underscore walk underscore foo underscore walk underscore, that is all. Check paths should not be equal to null. Error failed to create, failed fails to create the path. Then we enter a loop for I equals 0, I less than 4, I plus plus 0 into. So we want to load the image. Now we are going to load the image. Let's see. It's e to I. Let's put it string string to int 6. X to I, no, sorry, int to string, int to string 6. Printf, right? Yes. There we go. Printf. There we go. Number, and we define the number. Alright. Okay. So I'm going to load the images one by one to the surface array. First of all, let's generate the total path. Key string total path. Okay, so I don't separate it here. I first have to let me just go string, then we can concatenate. So CSTR3 to concatenate. Okay, concatenate character, concatenate a C string. Yes, I want to concatenate a C string. Now to concatenate a C string, right? So let's generate the total path. So I have first char num, right? All it is going to take is 4 just to be sure. Used for converting string I to a string. Printf num in the format of this, and then I'm going to do it right. Then num contains num contains this, right? So stdio each with print printf and then stdio. So I can just put here see which for using as print right. So then I have I which is going to be placed here. So first I concatenate distribution concatenate this first string, but can can I create an empty string here to here get set feature string. I can assign string a string. I can get a copy. It gives me a string, so I can simply write it simply just attempted to copy an numeric string from string B, and it returns B naught. If string B naught, B equals to null. This B naught equals B string. We allocate it as B string, right? So I can just copy it like this. Just go to pstrcpy from path, right? Right? pstrcpy from path. So this will return me. Then I can concatenate num, and then I can concatenate png at the. Alright, so first we'll check the path should not be equals to null. Error failed to create the total path. Okay, concatenate the remaining string. So what is the concatenation? Vcat cstr. Vcat cstr. Vcat cstr. This is. Wait, give me ah face oh, sorry. Okay, cat CSTR. This function is there. We go b cat cst r b cat cst r concatenates. I think we see right. Cat concatenate a string to a b string. Okay, how much does it concatenate? Until concatenates until there is no null character, right? Okay, so I concatenate up to the null characters, so I can just have it size to colon character, and then so I can simply concatenate total path, comma null. Then we cat CSTR total path, right? It concatenates, takes the data and equates it until these are not null character, and return pcat. Well, we get bulk, then so what does this return? It returns the PSTR. Okay, so concatenates need to explicitly besides the concatenate tail. Okay, dot png. So I would like to see the total path in action once. Say data, and this is total path. The where's game which we want, we need a bit font, right? We don't need this. Let's get it out of here. Source bitmap fonts. We don't need a not get texture, right? No. Okay. So we go here. Say bitmap font. Let's need this. Font. Nope. Okay. Right. So I'm going to create a data stream object, and then I want to data stream stream was none. Or I should be media. Okay, then we check the stream. So we go stream data stream to create check the null pointer error failed to create the string. Yeah, then we load media into the string, right? So data stream load media stream check r protocols r should not be false fail to load string media. Okay, let's try to have some things. No, but make widgets. Uh, we cat CSTR. That's why we cat CSTR. So temp image incompatible types assigning STL surface from void. I'm sorry. Oh, my bad. That widgets. Alright, I want to see if it prints the path correctly. Great, great, great. The path is correct. Okay, so we get total path finally. STL surface, we want to load data into surface. Loaded surface. Still, loaded surface is img load, and then we pass in the value. Load. Hope that's load. Pass in the path. So the data of total path. Then we check loaded surface should not be equals to null. Error failed to load the surface, load the image, SQL error, SQL underscore get error. I think it's right. Okay, img get error. SQL image error is img get. SQL image error img get. Then I want to convert the surface, right? Then go stream images of I equals STL converts surface information convert surface format. Format. Then we convert it into STL pixel format RGB8 and 4 times 8 here is the loaded surface. Alrighty, then we convert the surface into the format we wish to have. STL pixel format RGBA 888. That's how it is, right? Pixel format underscore. Store RGBA 888 and then save. Then we have to check. Do we check? Check. Then we see STL free surface. I think I should check stream image of I should not be error fail to convert the surface form. And then we free the STL free surface loaded surface. That is all. Okay. Then here, written success. Issue, graphical file, get buffer pixels. That's the pixels. Frame. Oh, so this function gets called again and again, so we decrease the frames. Okay. So it seems like it is getting really. So it will feel like something. Sign after here. I should really destroy these strings that I've created. Simply surface, then we destroy total path, and then destroy total path. Okay. Then we destroy path. Right. Destroy the strings. Windows. No, hold up. Let me just get. I did that right. Printf check concatenate, then let's load up and let's try if it works. Windows images of just still images still pixel format underscore RGBA. I forgot the additional 8 that then and it just loads up. Right. So we'll continue this one later. Until then, Maybe I can just, what else am I missing? Create a stream, then we create a blank texture, this will be a texture, and we enable texture streaming of this. So we go in here, texture, to create a blank texture, texture, texture. I think this should not, let me just fix texture, right, and everything else is redundant. This is its redundant. Okay, nothing, right? So I go texture, create blank, we take in the width and the height. So first create texture, to create texture to still create texture, should create blank. Okay. So I'm creating a blank texture here. I am doing this texture. So I do need to specify texture. Texture first we destroy the texture. Texture destroy texture. Texture mode destroy the screen. Okay, so the pre-existing texture is many. First, the pre-existing texture is many. Then we'll go create uninitialized texture. This is the format, and we set it texture access streaming with an uninitialized texture. Create an uninitialized texture. So create texture, specify the renderer. So pass in the window. Check window. So check error texture, then window should not be invalid window, passing the renderers, passing pixel format and texture access so format PL comma the access streaming then we have with check texture failed the texture still get okay. Then we set the width and height to be the given width and height. Okay. So then we simply turn else we create blank. So this is the type bool. Okay, bool here bool. Okay, so this should turn false and return true. Just space as text string. So let's just project and let's call it a day.